Okay, so what do we reckon for question 1? How many different distinct, keyword is distinct. Remember, distinct means different, okay? Arrangements are there of the word tweet. How are we going to work it out? Don't tell me the answer. How are we going to work it out? How many are going to work it out? Yeah? Yeah. Times 2 factorial. Are you happy with that, yeah? Because it's 5 factorial. Why? Good. 1, 2, 3, 4, 5 letters. But then you need to go back and remove all of those duplicate arrangements. Yeah? So you're happy there are 2 T's. There are 2 T's. Okay? So you need to divide by the number of arrangements of those 2 T's. Then also there's 2 E's. You need to divide by the number of arrangements of those 2 E's. Happy? Okay, good.
The 2's would be, so it's divided by 4?
It's divided by 4 in this case, yeah, exactly. But I'd write it like this, yeah, so you can see where it comes from. Yeah? So 2 factorial because there's 2 T's, then divide by another 2 factorial because there's 2 E's.
So it's, the number is 30, the answer is 30.
Is it 30?
So
120 divided by 4, yeah, 30. So the answer is 30. 30 different distinct arrangements there are. Yeah, good, excellent. Okay, what about the next one? Statistics. How many different ways are there arranging those such they're all distinct? 10, because, don't tell me the answer, tell me how you will get there.
10 number.
Good, 10 letters, it's 10 factorial different arrangements, divided by?
Divide by 3 factory plus 3 factory plus 2 factory.
Good, because there are 3 S's, so we'll divide by those. There are 3 T's. Good, and 2 I's. Do you get the idea? Yeah? So then finally for the last one, slightly different. You have 2 red cubes, 3 green cubes, and 4 blue cubes. How many different ways are there of arranging those? Sorry? 9 factorial because there's 9 cubes. Good. Yep, because there's 2 red cubes. Because there's 3 green cubes. 4 factorial because there's 4 blue cubes. Yeah, you happy? Good. And of course you can stick all this in your calculator and work out what it actually is, but I'm more interested in the process of how you get there. Okay? Key word there is distinct. Okay? If it didn't say distinct, could you get away with just putting 5 factorial for the first question? I think so, because we're not saying they have to be different arrangements, yeah? But the question in the exam, by the way, will always say distinct. Okay, so if it says distinct, you need to think about this. All good? Fantastic. So let's start putting some conditions on this. Now, really, there is no limit on the different conditions that we can have on these orderings. Okay? So think about this. Let's suppose I have the letters A, L, E, and X, and I want to know the number of different possible ways there are that I can arrange these 4 letters such that the 2 vowels are next to each other. What are the 2 vowels? A and E, right? So how many different ways are there of arranging the letters A, L, E, and X such that the A and the E have to be together? Any ideas? Ah, good idea, good idea. So what you could literally do is simply glue the A and the E together. You can think of the A and the E, if you like, as one object. And then you've got the L and the X here. Okay? So if I just simply glue the A and the E together, think of it as one object, okay? How many different objects now have I got?
3.
Good. So I can order these in 3 factorial different ways. However, that's not all of the different possible orderings I can have such that the A and the E is together. What do I have to do? Why do I have to multiply by 2 factorial? Absolutely. So because at the moment I'm just saying there's 3 letters, so there's 3 factorial different ways of arranging them, I've also got to think within this like glued letter, I can also have the A and the E the other way round. So I've got to think about the sub-arrangements of the A and the E. Hence I have to say for every one of these, there's going to be 2 factorial extra ways because the a and the e could be the other way round. Does that make sense to everyone? Yeah? Okay, good. Cool, and that talks you through it nicely. So there you go, there's 3 questions on the board there. Could you have a go at those for me? Okay, so can we go through these on the board, please? Right? Go through these on the board. So have a look at the first question. We have Alice, Bob, Charlie, and Rita. They want to stand in a line, but Alice and Rita want to stand together. Okay? So we need to work out the number of different possible arrangements we can have such that Alice and Rita are always together. So what I'm going to do is think about Alice and Rita as one person, like holding hands, they're hugging people, right? They're hugging people. So they're like one person, okay? In which case I have 3 people now that I need to order, okay? Excuse me. So how many different ways are there of ordering 3 people? How do I work it out? 3 factorial. However, in every single one of these 3 factorial ways, which is 6, every single one of these 6 ways, Alice and Rita could be standing this way round or the other way round. In other words, there's 2 factorial ways of arranging this sub-arrangement, this sort of one person, if you like. They can stand left and right, or Alice and Rita could be the other way round. So therefore, I'm going to have to multiply this by 2 factorial. Is that okay? Yeah. Good. All right. Have a look at question 2 then. In how many ways can the letters A, B, C, D, E, F, and G be arranged such that the A, B, and C are always together? So we've got A, B, C, D, E, F, and G. Okay. So A, B, and C now have to be together. So I'm going to treat them as one object. Then I know that they're always going to be together. If I say they're stuck together, glue them together if you like, then I know that they're always going to be treated as one object. Is that okay? Right? So how many objects have I now got that I need to arrange?
5.
5. Good. 1, 2, 3, 4, 5. So I've got 5 factorial different ways of arranging these 5 objects. However, for every one of these 5 factorial different ways, are you happy that there's 3 factorial ways of arranging this sub-arrangement? Does that make sense? Yeah? Because you can have A, B, and C, or you can have C, B, A, or you can have A, C, B, yeah? So 3 factorial different ways of arranging this sub-arrangement. So therefore, for every one of these, there's going to be 3 factorial ways to arrange that subgroup. Does that make sense? Does that make sense to everyone? Good. All right. Let's have a look at the third one then. Third one. So how many ways can the letters P, Q, R, S, T, U, V, W, X, Y, and Z be arranged such that the Q and U have to be together and the V, W, and X always have to be together? So again, I do the same thing. I just glue those 2 things together. So what have I got? I've got P right the way through to Z. I need the Q and U together. So I've got P, Q. I'm going to put the U next to it. Then I've got R, S, T, and then the V, W, and X. I've got the Z as well. Okay? So in other words, these are the letters that I've got. I'm going to glue together the Q and the U. I'm also going to glue together the V, W, and X, because I need those 2 things to be together. So I need the Q and U to be together, and I need these 3 letters to be together. So how many letters have I now got? 1, 2, 3, 4, 5, 6, 7, 8. You happy? Because remember, I'm just treating each of these 2 things as one object. However, for every one of those 8 factorial arrangements, are you happy that the Q and U could be the other way round? So in other words, there's 2 factorial ways of arranging the Q and the U. Yeah? And then for every one of these arrangements, these 3 letters could be in a different order. So how many different orderings are there of the V, W, and X? 3 factorial. Perfect. So you're happy that's your answer? Yeah? Happy that's your answer? Is this okay with everyone? Yeah? No questions?
All these are only one condition.
Yeah, well, this one is kind of 2 because you have to have these 2 here. But that's just one type of condition. Now, actually, on tomorrow's lesson, hopefully, if not Thursday's lesson, We're going to look at some slightly more complicated conditions, but this is just an example of a condition which you could have. So they have to be standing together. Okay? Right, okay, good. Now here's a problem on the board, okay? So a society needs to elect a president, a vice president, and a treasurer from its members. So you know that there are 15 members in this group, in this society. How many orderings, how many permutations can I have such that I have a president, vice president, and a treasurer from these 15 members? Can I give you 3 minutes to think about that for me?